So we're going to start word problems today. Have your graphic calculators ready to go as well, okay? Have them ready to go. And always remember that a parabola is symmetric, right? So you can cut it in half. If you have a point on one leg, you can actually find the one on the other side, okay? So we're gonna look at that as well. So this is in a nutshell the formula that we use. These are the x values of those 2 points that are at the same height. If you were to add them up and divide it by 2, you get your axis of symmetry, right, in a sense. You're basically finding the average of the two, if you think about it, right? Add this and this together, divide it by 2, you get half of it, right? You get the midpoint of it. And so it doesn't matter where you are, as long as you have, if I were to have this point right here and this point right there, I should be able to add up those x values, divide it in half, and I would still land on where the axis of symmetry is. Okay, so that's what we kind of talked about. And we had some examples here. How about we do one more? I will do this one here. Hold on. I'll do this one. Okay. So again, you notice that, right? You notice that they're both located at the same height. They could also be both x-intercepts, folks. If both of them had a 0 here, those are both x-intercepts, you can use them as well, right? Because they're along the same line, so to speak. And so we would say x1 is -4, x2 is 5. Just watch your signs, right? They may have both been negative. You should be okay with that. You divide that in half. -4 plus 5 is 1/2. So in this case, your axis of symmetry, right? We call it the axis of symmetry, but it's really the equation, right? It's the equation x is equal to 1/2. That would split the parabola into equal halves. Okay. So we don't need to do another one. I think we're good. I just had it there in case. So I'm going to move on to the one I skipped yesterday, which is this one on page 12. And notice the title, Finding a Missing X Value Using the Axis of Symmetry or the Vertex, right? And so this is where things are going to change a little bit. If you think about it, both of these values have the same y value. So you know, if you can kind of picture it, right, they would both be at a height of 5 on opposite sides of the parabola. And then they also give me the vertex. Now, if this is the vertex, then we know that that is the axis of symmetry, right? Which in turn tells me that x is equal to 6. Okay. Does that make sense, right? If they tell me that this point is the vertex, you're like, oh yeah, I know that that is my axis of symmetry. So that's already given. You're not trying to find it. You're trying to find one of these values, right? So this let's let this one be x1, and let that second point, the second x value, be x2. Right? So we're gonna work backwards here. Okay, so using x is equal to x1 plus x sub 2 divided by 2, right? We're gonna figure out what's missing. And let me zoom into that because I think it's a little easier to see if we're zoomed in. I don't need all of that space there. So we can take this, so many arrows, right? We can take that and substitute that in, right? So we have 6 is equal to x1, which I know is 3, right, from up here. X2, I have no idea what it is. And all of that will be divided by 2. So I'm going to use a different color just to show my steps. So this is basically like, remember, finding the number of sides. If I give you the interior angle kind of thing, it's the algebra around it, right? So we multiply both sides by 2. I want to get rid of that 2 dividing, right? So I can just go ahead and do that. You get to cancel those out. You get 2 times 6, which is 12 on the other side. We can now, sorry, that should be a plus, not a times. We can now just replace or get rid of the brackets. We no longer need them because it's no longer being divided by 2, right? So then on this other side, we go minus 3, right? We want to cancel that out, right? Because this gives you 0 in a sense. And this gives you 9. Okay. So you just found that that second x value must be 9 in order for you to have that point. So therefore, it's actually 9, 5 are the coordinates of missing point. Are the coordinates of the missing point. Right. So we could graph it, of course. I'm not going to do that. But this is an example of working backwards, right? And we're going to use that quite often. Okay. I've just got this idea here. Let's try to sketch it real quick. I'm just looking at my y values. Okay. You need to have it a little bit offset like this, if you can. And 3, 5. Let's go 1, 2, 3, 4, 5, 6, 7, and it keeps going, right? And we have to go to -10, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -10, and I have to go up to 5 here as well on the y-axis. I'm going to go 1, 2, 3, 4, 5. We're not going to make this fancy at all, okay? As you can tell. So 3, 5. 3, 5 is right here. And the point I just found was 9, 5, right? So I need to go 5, 6, 7, 8, 9. I'm going to go up to 10 here. But 9, 5, right? 9, 5 is right here. That's the second point I just found, the 9, 5, right? And the vertex is at 6, -10. Okay. So you should be able to visualize it now. Okay. So that is the, now that you have those 3 points, you have enough information to kind of picture that curve, right? How about we do this? 9, 5, 3, 5, and 6, -10. question. From 3 to 6, right? If you just look at the x values, how many units would you have to travel to get to 6? 3 units, right? If you were to go from the left, which the x value is 9, to get to the axis symmetry, it would also be 3 units, right? So it's 3 units to the center from either side, okay? So keep that in mind. All right. So there's your visual. Next. F of x, I know I started talking about this. We're just going to quickly say to describe the direction of opening, right? It's down because a is negative. The width, what would this be? Wide, right? Because a is between 0 and 1, right? A is in front of the x squared term, and the y-intercept is what? It's a bit tricky, perhaps. The value of c, yeah, some of you are saying 0. It's 0, 0, which is the origin, which is also the x-intercept. So keep that in mind. I will say also, in brackets, also x-intercept, right? The origin is both. So it kind of give away more than just the basic, okay? And we started, I don't know if this was in the homework, I'm honestly not sure. I didn't check to see, but I need you to be able to plug in an x value into any equation I give you, and you give me the y value resulting. Okay, so I'm going to kind of just block this off here, and I'll give you one more example so you know how I would do this. So f of negative 4. Let's do this. Let's fast forward real quick. What I'm basically saying is, hey, if x is equal to negative 4, give me that y value that would have to go in there. That's basically what you're doing when you're performing this calculation. Okay, so I use the one up here, negative 0.02. I plug in negative 4 squared, okay, plus 12.5 times negative 4. And so I basically want you to grab your calculators, and I want you to be able to do this. You can type in this first part in one shot if you'd like. So negative 0.02 brackets. You use the negative button there, not the subtract. Whenever you start something new, you have to use the negative. And so that gives you negative 0.32. So I just did this part, basically. This part right here gave you that. What's the positive and the negative when you multiply opposite signs? It's always negative 12.5 times negative 4. And that would give you negative 50. And so basically the next step is that you can go negative 0.32 minus 50. That gives you negative 50.32. And so that is the y value. This is actually a point on that parabola, okay? You just found a point on the parabola. And I know you're like probably thinking, okay, I kind of get it, kind of makes sense. I want you to really get it, okay? Let's take our calculators and press y equals. clear whatever you have in there. Type in this equation into y1, please, real quick. Negative 0.02 x squared plus 12.5 x. You got that? Graph it. It's not looking so good, so I'm like, okay, I'm in your shoes now, okay? I'm gonna try zoom 6. And it doesn't make sense. So here's where you need to think. Which way is this pointing? Like this, right? It's pointing down. So it's most likely doing this, right? Up, and it's going like this, right? You gotta imagine what it's doing. So I'm gonna increase my y max and the x max at the same time. So I'm going to my window. You pick your values, I'll pick mine, right? I'm thinking, I'm just gonna go x max is 100. Y max, I'm gonna go 100 too. It might be overkill, but this is a very important skill for you to know. Still not doing it for me. So I need to increase my y max. I'm gonna stop from in. I'm gonna stop going x max. I'm gonna increase my y max. I'm gonna go 500. You see it? I went y max 500. I'm gonna keep going up. I'm gonna go 1,000. You see it? Did I enter the wrong equation? Sorry, I'm just gonna double check. Oh, okay. You're gonna cut to the chase. Try 2,000, Mr. Dirksen. Stop. You know what? I'm gonna go big or go home. 3,000. And now I overdid it, right? But it doesn't matter. You're seeing the curve. So you're seeing this it going there. So what do I need to increase now? X max. So I'm gonna go. I'm probably gonna match it. That's just what I'm doing. I'm just gonna increase my X max until I start seeing the whole thing. You always have to hit graph, and there now I see the whole thing. I overdid it, right? So this is what I want you to think of. From here, the origin to here, it's 3,000. So that means that right about there is 1,500, right? So I can go to my window and just reduce that to 1,500 so that I see more of the curve. And I can probably go even smaller. Can probably go 1,000, right? Anybody try it already? Yeah, that would be a pretty good window there. I'd be happy with that. Okay, so we played around with, right, the calculator is going to be a bit of a learning curve, right? So we have to now figure, I want to practice this. When x is equal to -4, what's y going to be equal to? So let's try that. Second trace value, x is equal to -4. And what do you know, right? -50.32. It is exactly what I want. Except for it's y in the negatives, right? So it's actually probably somewhere down here, right? It's in the negatives. Yeah, right. Okay. So that is what we just did. We basically plugged in the x value to get our y value. Okay. All right. Let's switch gears a little bit. Maybe let's just answer this one here. If I give you an equation, what are the values of A, B, and C? A in this case would be this part right here, 74.3. Okay, it's just whatever is whatever's in front of x squared. B is whatever's in front of the x term, which is negative 3.75. C is the constant, so you have to write it down with the sign and everything. Okay, so the values in front of the variables for A and B, and C is your constant, right? So this is the leading coefficient. And this is your constant. So if I ask you to ever state A, B, and C, it's just, let's see. All right? We're good? Let's talk domain and range. Dun, 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 dun. Right. Okay. So when sketching the graph of a quadratic function within a context word problem, right, you must label the axes with words and units. Okay. Oh boy, that got taken out, but I think you still get the point, right? So you're gonna have to start labeling your x and y axis with time, and not just time. What are we in? Seconds. Is it distance in meters? Is it distance in yards? Is it height in feet? So you need to label it and have the units attached to it. Start just like before by finding the vertex, right? You need to find the vertex and the intercepts. This will give you a good idea as to what scale to use, right? To determine the scale. You need your intercepts and your vertex to determine the scale. Most of the time, variables will need to be positive. So I will say this, the majority of the graphs will be limited to quadrant 1. And by that I mean like 99% of the time. There are a few exceptions. I know one where a bird launches into the water and goes under the water, right, to catch a fish or something. There are a few exceptions, but for the most part, we stick to quadrant 1. Okay. And so let's say here, let's see the first, a classic example is you're given an equation. If you're in physics, this will look familiar to you, or maybe you haven't gone there yet. I don't know if it's 11 or 12 where you do motion, right? And so if you given an equation like this, I would have to tell you what do the letters represent. So height in terms of time represents obviously the height in feet, and t in this case, right, represents the time in seconds. So when you would, if you were to graph that, you need to make sure you transfer that information over. I would say that's the first thing you do, and you've seen me graph, so you know what I'm talking about, right? Time in seconds, height in feet. You don't need to have a title for your graphs, okay? In this course, you don't need to worry about that. And every point that you've looked at before means something when we're doing word problems. Okay? So watch this. The vertex, right? The vertex in this case would actually be time. Instead of x, y, it would be time and height. Okay? So your x and y is replaced with time and height. And this is the maximum height achieved at a certain time. Okay? Max height after a certain time. If you're ever asked to explain what did you just find, you found, right, how many seconds went by until you reached the maximum height. I will zoom into that a little bit. This used to be called, or we still call it, the y-intercept, right? This one right here. But that right now, or moving forward, will be our initial height. This is the initial height. This is your height you're starting at. And remember, you could be starting right on the ground, or you could be starting off the ground. It depends on the scenario. And I want you to understand that. Do you see anything happening in the other quadrants? No, right? So word problems, we're again restricted to just quadrant 1. And so we do not extend the line past the x and the y axis, okay? So that is that. This point right here, which we normally refer to as the x-intercept, is going to be, let me just move this up here. This is going to be the time, right? Object remains airborne. That's what that. There are various ways of referring to it, but in a nutshell, right? Like if you launch something here, right? It hits the ground here, so it tells you how long, how much time went by until that object hit the ground or the surface of the water or whatever, okay? And so that's what I want you to have there. Time until the object hits the ground and so forth. And specifically, this would also be referred to as time 0, right? Because at that point, the height is 0, right? So if we want to look at it as a coordinate, that's how you would refer to it. Here, this one would be when time is 0, you have a certain height. When time is 0, you have a certain height. Here, you have a certain time when the height is 0. So we still have our intercepts, but they mean something. This is the initial height in this case. At time 0, right, just before time starts running for that scenario to take place, you have a certain height, right? And vertex and so forth. Keep in mind that there's technically another x-intercept over here somewhere, right? If this curve were to continue, there's an x-intercept there. Do not find it, do not include it in your calculations because it's in the negatives. We can't have negative time, right? So you need to watch out for that. Next, let's move out here. Domain and range. Okay. For set notation, you have to make sure you use letters. Use given variables. Sorry, I'm gonna shorten it there. I'm writing down use given variables, and I'll zoom into that a little bit. If you want to use set notation, you have to use the variables that are in place there. So for domain, it will usually be this. Squiggly brackets. So we'll go from time 0, and in this case, we're using time, right? T for time, less than or equal to the x-intercept. Okay. And for range, it will be from 0, and watch, I'm using h, or you can use h of t. Both of them will be okay. And this is the y value of vertex. Yikes. So both are going to be limited, right? Your height and your time in this case. Interval notation, you just go from 0 till the x-intercept. Both have square brackets. And for range, we would go from 0 until the y value of the vertex. And you're probably like, what? So this is in general. I will have to emphasize that in general. There will be some exceptions, and hopefully I'm going to get you to practice. We will practice together before we move on. And then go over to 14. Let's copy this. Pause it there. Thank you. Appreciate that. For domain, you're going to go from 0, right? Time 0 all the way. Time flies, except for in math, right? Time flies until you get to 450. So you're basically looking at the x values that are allowed, right? So you would go from 0 to 450. Okay? And let's do our range the same way. When you're looking at range, look at your y values. So I'm going to go over here, start with 0, and I basically scan. You move up and you still see a curve, right? Until right about there, right? That's the highest y value that will go with you. And so you have to grab the y value in this case. So you're going from a y value of 0 all the way to 5,000. Sorry, is that 5,000? 50,000. 50,000. So from 0 to 50,000 is, in this case, what your range would have been. Okay? So, right, my range, which is there, this is the range, right? And, right, my domain goes there. Okay, so that one, I would say most students prefer this one because there's no variable, nothing. But if you wanted to state this as in set notation, which you have to be familiar with, you would do it like this. The domain here, you start with a squiggly bracket and you go from 0. And for domain, we're looking at the x value. So it's length, right? So what would be a letter that would apply here? I would use L, lowercase. And it has to be less than or equal to 450. Squiggly brackets closed. Right? So you're essentially saying the exact same thing, but this is in set notation. If you wanted the range, right, you're starting from 0, less than or equal to. The variable here is area. You can use capital if you want, right? I will always tell you the variables involved, right? So this is just for practice. Less than or equal to 50,000. And then you squiggly bracket at the end, okay? So interval is probably the easiest, but you should be able to do both. So this is the easiest case scenario. This is the one that you should be able to do without much difficulty, right? Next, let's try this one. Our domain and our range. Because the risk is so low, why don't you try that real quick? Just be ready to erase if you have to. If you had to put a number for domain and a number for range, just put something down. Big deal if you get it wrong. Okay. Ready? For the domain, I'm starting at the origin, right? So it's from 0 all the way to 17. Okay. Then for my range, a bit tricky, right? I'm starting there, so I'm going up and then down, right? But think of the curve. The curve exists down here as well, right? So technically, you're starting from 0, you go past the 15 because the curve still exists all the way up to here, where y is so small. Sorry, guys. It looked really big on my computer. 18, right? So you're going from 0 all the way up to 18 when it comes to the y values. Okay. And let's do this one here for the domain. Set notation 0, and I'm going to use t for time 17, and my range, I'm going from 0 all the way to 18, and I'm going to use h all the way to 18 like that. Okay, so that's that. Homework, these two. Homework. So try those. I will I'll probably scan it. Yeah, I'll scan it right after we're done today, and you'll be able to check if you got that right. Next page. I think this is the only thing that's on this page. I left that blank so I can add something later on. But there are two nuances here. Okay. If b is equal to 0, right? When this coefficient is 0, your parabola will actually start. It'll be that the vertex and the y-intercept will be the same. Okay, vertex and y-intercept are the same. It's just the only reason I mention it. Sometimes it throws students off. If I ask you what's the vertex, you go ahead and find this thing. If I ask you to find the y-intercept, go find that thing. But they're perplexed that they're both the same, right? And it's simply like technically, right? It continues here, and it just so happens that when b is equal to 0, it's going to be right on the vertex is going to be right on the y-axis, and so is the so if b is not equal to 0, right? Vertex is not the same as the y-intercept. That's all. That's all I wanted to do with this slide here. So there's really not like it shouldn't throw you off, but some students doubt themselves when this happens, right? They're like, tell me the vertex, tell me the y-intercept, and they get the same answer, and they're like, can't be, right? Something is wrong with my calculations. It's not. Right? So let's go over to word problems. So essentially, not much will change except for the fact that we stick to quadrant 1. So it makes the domain be different. That's why I had to talk about domain and range before I move into word problems. So if you're tired, I don't know, like go get some snow or whatever and put it on your face to wake up. Okay. All right. So equation is provided. So word problems where the equation is provided. The path of a baseball that has been hit can be modeled. Watch this, right? You can model the path of anything using quadratics, right? If it's motion. And so this is the equation where h of t is the height in feet, time is t is time in seconds, no surprises there. But what I want you to think of is that every single point on this particular graph will be time and height, okay? If you graph this and you find coordinates, the x value represents time, the y value represents height. I think you can wrap your head around that, right? I will never flip this around on you. You always know that the right side is where your x values are, the left side of the equation is your y, okay? So let's type that in. First and foremost, let's type that in, and let's get a good window on our calculator because I'm going to use it quite often. So y equals, let's clear everything. Oh, there's a typo. This is a negative, folks. Negative 4.9, very important. Negative 4.9 x squared plus 35x plus 4. Okay. So obviously we don't have t, so we just have to type in that x there. And let's go ahead and graph this. And you're probably not going to see anything. So I kind of do a lot of these things on purpose, okay? I'm going to go zoom 6. Oh, and something happened there, right? We knew it was going to point down. So we just have to increase our y max a little bit. Let's go ahead and do that. What do you think? I'm going to go 300. Oh, that was overkill. It's a bit too much. So this is 300, this is 150. So let's go 150 for y max. That's pretty good. I don't need to see a lot of the negatives for x min. So I'm going to go window. I'm going to go x min just -5. That is a pretty good scenario there. Do you remember the problem with the bottom here? Do you remember that it will block a lot when you just leave it like that? As soon as you try to find second trace, it's going to block. So we need to fix that. So y min, I would go -50 or something like that. I know it's frustrating, but you need to leave yourself enough space down here so you're not blocking your graph when you're trying to find things, okay? So here, look at my window, write this, copy this real quick before I start. If you want the exact same window as I have. And let's get started, okay? So A is asking, what is the initial height of the trajectory of the ball? In other words, what was the height, at what height was the ball hit, right? That's basically what I'm asking here. So for A, let's say that the initial height is at the y-intercept. Okay. And the y-intercept is 0 what? 4, right? So I want you don't have to later on do this, but I'm just explaining this. That's the initial height. So initial height is 4 feet, okay? Initial height of the ball is 4 feet. So you state the coordinate, but then you need to tell me which one of those two numbers is actually telling us the initial height, because it could be 0, right? We don't know, but it's always this value right here. B, determine the maximum height of the ball. Max height is found at vertex. Okay? Maximum height is found at the vertex. So let's go ahead and find that. Keystrokes. Second, trace, max. I will also tell you this. Most parabolas are going to be pointing downward because motion, right? You hit the highest point and then it hits the ground, right? So sometimes students forget a negative and they answer everything, and it's like, really? You really think it's going to be pointing up, right? If you're hitting a ball, so it's going to be pointing down. So let's go ahead and find that. Second, trace, it is the max, right? So it's asking for left boundary, and I'm already at the left of the vertex, so I hit enter. Then you go to the right, hit enter, and guess it's always enter. And so you get 3.57, 66.5. You actually are getting two pieces of information there. So tell me that you're going to find the vertex, but some students just leave it like that. It's like, there, that's the maximum height. But I technically don't know if you know, right? This is the maximum height. Maximum height is 66.5, and we're talking feet. So always look, is it yards, feet, meters? What are we talking about? C, how long does it take for the ball to hit the ground? In other words, let's read that here. In other words, how long does the ball remain airborne? That's basically what it's asking. I'm asking the same thing with different words, right? Find x-intercept, positive x values only, okay? So some students give me the negative x-intercept as well because they just put on their study sheet, find the x-intercept, right? And you don't want that. Time is positive. So forget this one on the left because it is in the negatives, okay? So we go second, trace, no, sorry. What do I need to do first? Y2 is equal to 0, yeah. And let it graph, and then go second, trace 5. I need to go closer. Watch what happens if I just keep it here. Enter, enter, enter. You get a negative, right? It found this one. It's just slightly negative, but it is negative. I can't use that one. Should I do that? Here, for your notes. For your notes. And let's find the other one. Second trace 5. No. Come on, work with me here. Okay. I'm going to go all the way over past the vertex, and then you're closer to the other side. Okay. Enter, enter, enter. 7.26. Rounded, right? Always 2 decimals. And I will quickly, I will just answer this way. This is basically, your calculator is doing all of this, right? Nothing happens here. The ball starts at time 0, right? And it flies until it hits the ground right here. After 7.26 seconds, right? So do not use that one to figure that out, right? So don't use this one. It takes 7.26 seconds to get there. Okay? Do not use the negative in this case. It starts at time 0 and it's being hit 4 feet off the ground, right? That's when the clock starts, right? D. What is it? Read with me, okay? I'm looking at D here. Calculate the height of the ball 1.5 seconds after being hit. So basically what it's asking is, hey, if x is 1.5, then what is the height? Right? Time, height. Oh, I didn't do keystrokes, folks, for Z. I'm always so picky with that. So y2 is equal to 0, second trace 5. Let's just add that as our keystrokes. So when you know the x value, you go second trace 1, x is equal to 1.5. And I will figure out what y is at that point. Second trace 1, 1.5 is my time. And it actually shows quite nicely, right, that my height there is 45.48. 45.48, right? And so if you put feet after this and you circle it, then I'm fine, right? So the ball is at 45.48 feet at that point. Take a deep breath for this one. This one is going to be worth 2 marks every single time, the one you're about to get here. So for E, let's read the question there. Read with me, determine the time the ball remains at or above 49 feet. So this is, I would like you to have a little sketch for this. Okay? So just make a little sketch, right? It starts somewhere here, it goes up, and then it hits the ground. Okay? It starts at 4 feet, right? And then it goes up somewhere is the 49 feet line, right? You have to imagine there's that height. That is my 49 feet height. And so the ball gets hit right here. It goes up and then it reaches 49 feet here, keeps going until it goes back on its way down. It will get there again. Okay, so there's a time frame that elapses between these two coordinates. Watch what I do. I just go down and I call this time 1. And I find the second one and I call this time 2. And we're going to find those 2 times. So I will let y2 equal to 49. And I'm going to go second trace 5. You're essentially doing the exact same thing as finding the x-intercepts. It's just now it's higher up on the curve. Okay. So follow me there. I let y2 be 49. Whatever it is, right? Whatever height I'm talking about, right? You just type that in. And when you have that, you hit graph, sorry. And it should right there. See how it cuts it? So I need to find both of those intersections. So let's go ahead and do that. Second trace 5. I'm already closest to the left, so I'm going to go enter, enter, enter. And watch this. I'm writing 4 decimals down. Otherwise, you're going to get and a rounding error if you round too soon. So I'm going to write down 1.6816 rounded to 4 decimals. And then I will do this one more time. Second trace 5. I'm going to go over the hill to the other side. Enter, enter, enter. 5.4613. Rounded to 4 decimals, right? If you do this, you would get 1 mark already. You get 1 out of 2 for finding these two. Okay? But it's delta time that you need to find. Delta, I'm sure you've seen that in science, or it's the difference. Delta is the difference, right? So we're going to go time 2 minus time 1. If we subtract these two times, we find out how many seconds, in this case seconds, right? That ball remained at or above 49. So we're going to go 5.4613 minus 1.6816. And let's go ahead and do that. 3.78 is what I get. That would give you a 2 out of 2 right there. If you actually go ahead and subtract them, you get full marks. At or above 49 feet. And that height could differ. It could actually ask you how long did it spend below 49 feet. What would you do there? How much time went by in total? Let's go back up. 7.26 seconds, right? Minus this, you get the time below, right? Does that make sense? Right? Your total time is 7.26. So you can answer it. You can answer both questions by doing this. Okay. Let's keep reading. Graph this scenario. That's fun, right? And I provided a graph for you, so a grid, I mean. So let's go over to the next page here, and let's do that. I'm going to transfer over very important information here. I have the vertex is 3.57, 66.5, and I'm transferring over that positive x-intercept, which is 7.260, and that's basically all I need in this case, right? So I transfer that over, and I determine that this axis here is going to be time in seconds. Graphs are going to be worth 3 marks most of the time. So height in feet, get that out of the way. And I'm going to, my x-intercept, as long as I go up to 8 or 10, I'm good, right? So I'm going to see here, 2, 4, 6, 8, 10 works beautifully. 2, 4, 6, 8, 10 works perfect. The highest height I need is 66.5. So if I go up to 80, I'm golden. So let's see, 10, 20, 40, 60, 80. Yeah, that would work. You could go up by 10. No, 10 wouldn't work. 15 would work. But I don't do that. So 20, 40, 60. The hole punch there knocked out some of our grid. That's fine. So watch this very carefully. I didn't do that, sorry. Y-intercept, I determined was 0, 4, right? That is also important to me, the y-intercept. So you're not starting at 0, 0. This graph should not be right at the origin. This is 10. This would be 5, so 4 is right about there. 7.26, this would be 7 right here. 7.26 is just over, make a dot there. And the vertex is 3.5 is right about there. And I'm going to go to 60, this would be 70 there. So 66 is right about there. Okay, and then you use your artistic. I don't go straight to the vertex, right? I always go out a bit and I curve in. And then I do the same thing there. I could have probably used a bit of a different scale to use up more, but this is I would be more than happy with this. Okay. Height in terms of time, negative 4.9 t squared. And I already forgot my equation. Hold on. I'm like Dory in Finding Nemo. Somewhere in here, I have it here. Plus 35t plus 4. So labels, that means axes and the equation. Scale, graph, the points are where they're supposed to be. The shape looks like it's supposed to be a parabola. And looking at my time carefully here, we still have more to go, right? Namely, domain and range. So let me just check what comes next. If it is, in fact, domain and range. I want to read it carefully, and I'm going to highlight here. State the domain and range of this scenario. We assume that the ball stops upon hitting the ground. So I'm going to ask you to state the domain and range in two different scenarios, because I don't have enough time to do a whole other question. So we're assuming that the action stops when it hits the ground. Basically, the way our graph is, right? So that is G, sorry. G, my domain, I'm just going to do it interval notation, okay? My domain goes from 0 all the way to when it hits the ground. Okay, time goes from time 0 till time when it hits the ground. By the way, when it's time, it's always starting with 0, okay? Range, it hits the ground, correct? That should give it away that 0 is the lowest it gets. Up until the highest point, which is 66.5 feet. This is, right? This is the x-intercept, and this is the y value of the vertex, right? So when you look at that chart I gave you, right, that kind of gives you a bit of a help on how to state your domain and range, then that's how I do it. So if you don't have those, you need to get them. Okay, you need to get this and you need to get that if you don't have them. Most of the time, by the time you graph, you already have all of that information there. Next, the other domain and range. So try to follow along here. H says, state the domain and range of this scenario, assuming that the ball was caught 6 feet above the ground. Different spin to it. Say what? Assuming it was caught 6 feet above ground. So let's go to the back. And for H, I'm going to give you a little diagram, just a sketch. Time, height. We start at 4 feet off the ground. It gets hit. And now it will be caught. it should be a little bit higher than where we started here, right? Did the maximum height, did that get affected? Absolutely not. This is still 3.57, 66.5. This is still 0, 4. This is what? Do we know the time? No, right? But do we know the height? It's 6 feet, right? It's being caught 6 feet above ground. So we need to know that because time started here. It's balls in the air until it gets caught. So our domain has changed. It's no longer when it hits the ground, it stops there. Does that make sense? I hope so. So what do we need to do to get this done? Y2 is equal to 6. Second trace 5. Y2 is 6. I'm going to clear that. 6. Hit graph. Hopefully we can see that one. Oh, just barely. But it's there. Did you see it? Your x-axis is just thicker now. So second trace 5. I'm going to go over to the other one here. And what do you get? You get x is equal to 7.09 seconds, right? So this is the time where it's caught, right? Caught after 7.09 seconds. So even though it's so, the time is so almost negligible, right? The amount of time that is the difference. We would say that the domain is 0 to 7.09. Okay, this is the new time. The time for this in this scenario went from when it's hit to when it's caught. So it's no longer your x-intercept, right? And by the way, I will never do this on a test. I will never have this many questions off of one word problem. But I'm trying to get you to see, just using this one scenario, everything that could be coming your way. What about the range? This is a tougher cookie. What's the lowest height the ball is ever at? It doesn't hit the ground, so 0 is out of the question, right? 4? 4, right? Because when at the beginning, it's hit at a height of 4 feet, right? So 4 is my lowest, and what's the highest? 66.5. All right, so you didn't fall for the 6. I wanted you to fall for that 6 and put that in here, but you didn't fall for it. Good, good. If you did, don't tell me. I'll never know. So that is your domain and range, and this is almost like a different question, folks. I don't think it's fair to do this in one shot, but it should have been a different question altogether, right? And we're almost done, right? 7 minutes left. So I just want to finish that one. Write another equation. You have to write another equation, right? That would model a path with a lower maximum height. A lower maximum height. How would you do that? This is where you need to know your A, B, and C, right? I it is, right? And here we would say change the values of A or C. I would focus on those two values. Do you remember what, sorry, I'm going to block this for a bit. bear with me. I should have had this ready. You remember what C does? Watch what's, I'm going to make this like this, yeah. The value of C, if you were to change it on the equation, if you increase the value of C, you're saying you're increasing the y-intercept, but you're actually increasing the whole curve. So the value of C, changing it will change the maximum height. Also, the value of A, see how the height goes a little bit higher, right? Like as you increase, you have to be careful, but it can be done using either one of them. I personally would use C, if you ask me. That's the easiest one to do. And you don't have Desmos available to you, right? But this is what I would do. Try typing in the exact same equation, but change like instead of 6, enter 8 or something, right? And graph it at the same time. So if you're ever on a test, you're like, let's see if I change this, what happens? Would that be a higher max? And you graph them both. This is the first one. And the second one is not going to be, it's just barely higher. Not noticeable on the calculator. So I'm going to go a little bit, I'm going to go plus 20 at the end so that it's more visible. So if you increase the C value, there it is. That would model the path of a ball that has a higher maximum height. Okay, increasing C will shift graph upwards. So example, I would just do this. H of t is equal to negative 4.9 t squared plus 35t plus, let's say, 15, right? I've changed that C value to make this happen, right? And that's everything for today. I think your brains are probably smoking right now. Here's your homework. Homework is pages 6 to 9 in the workbook. Yeah. Did it? You never saw this, right? See? Can we change that? It's 1.5 or something lower than 4, right? Thank you, Jeremy. My viewers would have been curious on that one. As I said, read your questions.